Hey everybody, hope you're doing well today. We're going to do a video on solving the Project 2 Connect 4 game here for you. So I got a project all started up here. Let me see, make sure we have everything that we need. The idea was this Connect 4 class will have a couple functions in it and then some unit tests for those classes as well. I know I had asked for you to play the game, but there's no points for it. So as long as you have the class and the unit tests, that's cool. So maybe we'll have a little, actually being able to play later. But as far as the project was concerned, we're just going to write the class and the tests, and we can go from there. And then on Thursday, we'll talk about inheritance. That's what's on schedule for the week. Again, we don't need to go super deep on inheritance. We'll cover some of the basics of it, but we'll get to that next semester if you guys are going to continue on. So let's start with our Connect 4 class here. And just to make things simpler, I'm going to put it in its own module. So I'm just going to make my own Connect 4 module for it here, and we'll have a class for Connect 4. Let me zoom in a little bit here. Okay, and then we'll need an init method. So this init method here is going to set up the board, and I want that to be private, right? So the little underscore there is a list, and now we need to add all of the empty spaces to that list. Now I want to say, so for row in range, a Connect 4 board has 6 rows and 7 columns, right? So I want to range 6 at every row, right? And then for space, or I don't know, column maybe, in range 7, I want to do something else. So my board is a list, so I want to add the list inside of the list, add the second dimension here. So I'm going to take self.board, and I'm going to append an empty list. Right, and then inside of this for column now, I need to add these blank spaces. So now I'm going to take my self.board at index of the row, right? Because that's the row. And maybe I'm going to rename this here. Let's refactor rename. Call that row index. I like that much better. So the board at row index is the row at which we're currently in. That's the second dimension. We're going to append just a space character. It's open, right? So we'll have X's, we'll have O's, and we'll have open. So this will add 7 spaces to every one of the 6 rows. Is that right? Let me double check. Connect 4. Let's look. Make sure I got that right. So 1, 2, 3, 4, 5, 6, 7 columns by 6 rows. Okay, perfect. I did have that right. Okay, so that's our init method. And then we need to add ways to interact with it with this drop piece, figure out whether or not we're tied. We have winner by row, have winner by column, have winner by diagonal. This sort of just functionally breaking it down, doing that functional decomposition. I hope you guys talk about that at your Thanksgiving virtual gathering, right? We're hopefully staying in our pods. So, oh, that's the wrong window. So we'll come back here. Okay, so that should set up the board. And then I need a current player. Current player. And you either make this public or private. Typically we don't want people to change the current player outside of our logic. So I'm going to make it private here. And I'm going to set it to X. And then I'm going to add a method for getCurrentPlayer. That way I can tell them who the current player is, but they're not going to go change it. Because if I make that a public variable, then it's possible they would go and change it and say, oh, I'm just going to change who the current player is. Oops. Help if you spell player right. Okay, so we'll just return the current player. Okay, and then we're going to do that drop piece. Drop piece, and that needs to accept a column index. Right, so which column do you want to put this in? And first we can do some sanity checking. Right, we can say if my, if 0 is less than or equal to the column index is less than, we have, well, we know it's 7 here, or if we wanted to be flexible, we could go off the length of self.board at, index 0 or something. Sure, I mean, let's just say 7, because we know it. It's Connect 4, it's pretty hard-coded. So 7 is not a valid index, and this one is fine. And really, we want the opposite of that. So if it's good, we'll keep going. And, sure, else we'll return false. Like, hey, you can't do that. Again, we could raise an exception. I don't think I asked for that here, anything specific. I just said do it here. So we could give an exception. Yeah, there wasn't any request for it there. Yeah, we'll do that. We'll raise an exception. Raise invalid argument, right? Or argument. Oh boy, where is it here? Where's my error? Or value error. Value error. That's what it is. Value error. must be, what, so column index be between, oh, sure, must be 0 to 6. Column index, sure, we'll do that. And that's like kind of a little bit ugly to have that there first. So I really do want to flip this here. So I want to say if it's column index is less than 0 or column index is greater than or equal to 7. Let's raise this error. Because then I don't need an else and it doesn't have to be tabbed in. So it's a quick little check here, make sure it's valid, and then we'll continue on. I get just a nice practice here. Make sure it's in bounds. Then we need to try and drop the piece. Okay, so we're going to try, right? So we're going to say for row index in range, and now we need to actually start at the bottom because we want to, the piece should try and fall to the bottom and then work its way up. So we want to start at row index 5. We're going to go up to 0, and we're going to step by -1. And we're doing those ranges that way. And actually, we want -1 here because we want 0, and otherwise it wouldn't include 0. We want the 0th row here. And we're going to try. We're going to say if the board, if self.board, right, at the row index, which is going to start at 5, the last row, and then up and up and up and up, at the column index is blank, then I can drop the piece there. Then I'll set the piece equals self.currentPlayer. Then I need to change current player, right? So I can change current player. So I can say if current player is equal to an X, then current player should now be equal to O or something, right? I don't know if you want to do X's and O's or reds and yellows, however you're doing it, right? And if it wasn't an X, then set it to X. Right, so if it was an X, flip it to O. If not, put it back to X. You could use one of those ternary expressions for this if you wanted and get fancy. That's no problem. Again, I just get confused by those easy. So, and if else, it sure takes a little bit more lines of code. I don't care one way or the other. This should be fine. And this should check now, right? Starting at row 5, go up, 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 and eventually it should set. Now we might want to do something, right, where if it doesn't work, we raise an exception or we return false or whatever we're doing here to let them know that, yes, this worked or not, right? So I kind of like the idea of, let's see. So if we do set it here, that's good. Yeah, how about we'll set that and then we'll just return through. Or we can just return, I guess. I just return and that ends the function. Return. And then if we don't return, then we can raise a value error. And we'll say, we want to say like there's no, this column was full or something. Column was already full. Sure, something like that. Okay, so if we didn't return at the end of this, we found an open space, we'll raise the value error. You could use a break in the loop too, and then maybe have like an else in the loop, but I think this is fine. I think this works out pretty well here. So, cool, so we got drop piece, right? And then we need other functions, right? Is tied, has winner by row, has winner by column, has winner by diagonal, that sort of thing. And really all of that sort of is, part of is game over. And you don't need a function like this, but if you had it, great, that's cool. So the game's over if self.is tied or self.has winner by column or self.has winner by row, right? We'll have any of these cases here, or self.has winner by diagonal. Right, we need that little backslash because they're going on a line. So if any one of those is true, why did that not space right? That's annoying. Okay, if any one of those is true, the game's over. Sure, so that's just one quick little check. And then we can define the rest of these functions here. Define is tied. So is tied is if there are no spaces and the game's not over, or there is no winner. Right, so we can check. So we can say, if really we need, okay, so we need to look at each row and see if there's a space. So if there's a space, it's false. So we're going to say for row index in range, or no, we don't even need to do that, right? We can say for, we can just do an enhanced for that. We can say for row in self board, for, so each row then is a list of characters, and if the space is in the row, return false. Right? We can't be tied because we found a space. If we went through all of our rows and we haven't found a space, then we're going to return. We're going to do the opposite of this, right? If there is a winner, we're not tied, that's false. So we want all of that in parentheses, right? So we're going to check for winners. So if we found a space, false. Otherwise, if there's a winner, it's false. So we're going to return not winner. It's a little bit ugly there. I'm not super proud of the not here. In this case, you might want to say if there's a winner, return false, else return true. But I usually get upset when people say if this, return true or false, because we could just do a not here. This is not a winner. Okay, so if we don't find a space, we're going to return not there's a winner. Because if there is a winner, it's not tied. But if there's not a winner, it is tied. We should get back true. Right, hopefully that makes sense. Right, then we need to tackle these winners here. So we'll do winner by row is probably the easiest one to do first. So we'll do has winner by row itself. All right, so now this one we need to check each row, and we're looking for 4 in a row that match. So we're going to say for row in self.board. Let's go look at each row. Now I want to look at and see if any 4 of the positions match that are not a space. Yeah, that's kind of ugly there. But what you can imagine here, right, this connect 4, there's a nice one on the board here. This one like a big board. You can kind of imagine if there's going to be 4 in a row, the middle space is going to be included. Right, because you either going to start at the beginning and start to here, get to the middle, or start at the middle and get to the end, or so you can only start in column 0, column 1, column 2, or column 3, and have 4 in a row. But you're always going to have that middle space, the middle one not being a space. So we can check, right? Again, there's lots of different ways to go about it. This is just one approach here. So we're going to say if let's say for column index in range, so we're going to go from 0 to 4 because we want 3. Right, so we're going to go one pass. We want index 0, index 1, index 2, and index 3. We're going to start with those columns, okay, for each of those. Okay, and then we're going to say if self.board at, if the row, right, so if row at the column index does not equal a space, so it means it's either an X or an O, and then they all need to match. Equals that of column index plus 1, and, oops, sorry, we need those backslashes here. Row at column index equals row at column index plus 2, and row at column index equals row at column index plus 3. That's a little ugly here, sorry. We're saying, okay, we're not a space, and the first one matches the second, the first one matches the third, and the first one matches the fourth. If they match and they're not a space, they're either all X's or all O's, we can return true. We have a winner. If we check every row and every set of columns from index 0, index 1, index 2, index 3, looking at the next 4, then there's no winner. We'll return false. Okay? Why is it unhappy with me now? What's it not like? Let's give it a minute. Something about the spacing, right? Reformat. Sure. Okay, so that's winner by row. Great. Now let's do define winner by column. As winner by column. All right, so now by column, I need to check individual rows, but I know that I only need to check, because if I need 4 in a row, I need to check row 0, down, row 1, down, and row 2, down. We're going to do the same idea here, but now we need to use indexes. So we're going to do row index. Or I'm sorry, we're going to do each column at a time. So we're going to say for column index, index in range, and we want to check from 0 to 7. So 0 to 8 will give you 0 to 7. Now we need to check each of those sets of 4. So now we're going to say for row index in range, and we're going to go from 0 to 2, so the 3 to get inclusive of 2. We're going to check the first one. We'll say if my self.board at row index, at column index, does not equal a space, right? And let's check that they match, right? So if it matches, then, but now this is column plus one, same, I'm sorry, row plus one, same column. If this one equals that one. This gets a little bit wordy here, sorry. So, yeah. Oh man, that's kind of long. Let's see if I can shrink this down. Okay, it's close in there. It's close. And so the first row matches the row below it, and the first row matches the second row below it, and the first row matches the third row below it here. If all of that's true, then we'll return true. We found a winner, right? It's not blank, and I have 4 that match. Space is here. Okay. If I go through all those loops and I haven't found a winner, I'm going to return false. Okay. Now the last one here is diagonal. So diagonal is a little bit tricky here. Has winner by diagonal. Oh, that should be a function call too. Oops. By diagonal. That would have been a problem. Has winner by diagonal. So let's define that one. Define has winner by diagonal. And now this one, now we either want to do diagonal up or diagonal down, or we can do them both at once. Either way is okay. So what we're going to do the same idea. So I know with the diagonal, I have to have 4 different rows and 4 different columns. So my starting rows, I only need to start at row 0, 1, or 2, because I can't go 4 down if I'm looking at the down. And then I can only go through columns 0, 1, 2, and 3 if I need to have 4 more columns across. For the diagonal up, we're going to do the opposite with starting at the lower rows going up. So let's let's break this up. Let's return self.has winner by diagonal up, or self.has winner by diagonal down. Nope, we'll just return that. Okay, and then we'll define those ones. And really, maybe those ones could be private methods. You can make methods marked as private, because we don't really need to check any of those. So, sure, we can make that a private method here. It's just a helper method. So do the diagonal up. And, let's do down first, sorry. Let's do down, because I think down's going to make a little bit more sense. So we're going to look at row 0, row 1, and row 2 through columns 0, 1, 2, and 3. We're going to say for row index in range 0 to 3, because we want only 0, 1, and 2. And then for column index in range 0 to 4, because we want 3 inclusive. Now we need to check. So if self.board, we're going to do the same thing. At row index and column index is not one of this. It's not a space. And now we need to check that they match as we go diagonally down. So I'm going to take this same line up here. So it's the same first position at row plus 1, column plus 1. That'll go diagonally down, right? Going down a row plus a column. And we're just going to do that a couple times. And then is it plus 2 and plus 2? And is it plus 3 and plus 3? Return true. If we've done all of that and we haven't found a winner, we'll return false. Right? And then this same exact thing is going to work for us here for has winner diagonally up. But now we need to check different ranges of rows, right? So we're checking diagonally up. We're going to start at index 0, 1, 2, 3, 4, and 5, because I need to go upward. So it's from 3 to 5. So I want to range from 3 to 6 to get me 3 to 5. And now my rows are going to go -1 because I'm going up, -2 and -3, but still columns are going up because we're going over columns. Right? So what that's going to do, it's going to check each diagonal going upwards, upwards, upwards for each row, and then go to the next column. Or each row, it'll look at each column. This way, this diagonal, and this diagonal, and go to the next row. This diagonal, and check them all. So that should check all of them for us here. Return false. Okay? So we've got that. Maybe, make those ones actually kind of, I'm feeling bad that those are public now, so I'm going to rename these ones here. Because we don't really care. We don't want each person to have to check each time here. By row. And then we'll refactor this one. Has winner by column. And has winner by diagonal. I'm going to refactor as well. Okay, we'll do that one. And then I just want to have a has winner. Define as winner. And then we can just return this one here. Any of our winning positions here. Right, we can define. What's going on here? Okay, there we go. So that's has winner. And then we can clean this one up and just do self.hasWinner. Has winner. Right? So there's no space and we not have a winner is our tied. So it just cleans that up a little bit here. And the same has winner, self.has winner. Right? We're tied or we have a winner. Now we can put that all in one line. Looks a little cleaner here. Does that make sense? So our public functions then is game over, is tied, has winner. I don't know if is one, I don't know, sure. Any way that we want to be able to check this. Right? This is the way we want people to interact with our class in the public manner. So I can get the current player, we can drop pieces, we can check if the game's over, the game's tied, has winner. These other ones are just our private helper functions for us to do that functional decomposition. So let's give it a try. Let's see if we can do some testing here. So let's click, oh man, up at the top. Here we go. Go to tests. There we go. And we'll create some tests. So we want to test. We want to test drop piece, test game over, test is tie, test has winner. I don't know. Sure, we can test these other ones too. Not a big deal. The get current player is I'm not super excited about, and we can test that when we do drop piece as well, because we use that really. Like we know it changes in drop piece, because that's the only way to change it here. Okay. So we'll set up a couple tests. So what I want to do here with my arrange, act, and assert, I'm going to say, okay, I want a new connect4 board, so I need to import. I'll say from connect4, import connect4 from the module. So I'll have my game equals a connect4. And then we're going to act. We're going to drop the piece. So now, in here, I'm sorry, I'll have an expected. I don't know. This one's even kind of silly to check in here. So we'll just do this here. We'll call game.dropPiece, and we'll do that in column 1 just for fun here. And then we're going to assert that game. Now here's where it gets silly. We can sort of cheat here because I can get at that private board. So at row 6, column 1 should be an X. So I can assert that here. So I can say, oops, self.assert true. Or sure, assert equal. Yeah, why not? So game board at 6. I'm going to have my expected first, and then the actual. There we go. That's not too bad. So like I could have an expected piece, but like, I know it's X. I don't know. I'm not too sold on this. We can test this even better too. We want to also call drop piece, column 1, and then I should have a O here at 5. Right, each time. So and I could keep on going. We could check those exceptions. Right? The idea was that we had 100% code coverage, so I'm going to have to test those exceptions, right, when we get there. And then testing for game over, right? Anyway, I want to do the game over, great. And tying is a little bit tricky. You can drop all the pieces, or this one I want to show you a little way to cheat here. Actually, I guess I need all of that here. So because I can change board, I'm going to take game.board equals, and I can just give it my own 2D list here. Now I do need to be careful that I don't screw this up. So let's do X and O and X and O and X and O and X, right? So that's 7. 1, 2, 3, 4, 5, 6, 7. And we need 6 rows here. 1, 3, 4, 5, 6. And now I need to flip halfway through. So I'll make this one, bump that down, that down, and then I'll add in another O here. Right, so this shouldn't have any winners, but it should be a full board here. Right, so we have a bunch of 3 in a rows, a bunch of 2 diagonals, but no winners. So that, if I change the board without having to call drop piece a bunch of times, I can kind of cheat. And then I can say self.isTrue, or assert true, game.isTied. So that should be a tie game, right? And then I can do these same sort of things for have winner if I want. Like I can just put a winning board in here. It's probably better to use drop piece just to make sure drop piece is going, but you know, I don't really want to have to drop 42 pieces in, and then I'm going to forget which one I'm doing because I have to alternate. So I'm okay with cheating here for tied, but let's do the real one for winner here. Right, so for winner, if we drop piece 1-1, and then drop piece in 2-2, and drop piece in 3-3, and drop piece in 4-4, or just one more in 4, right? That should put the X at 4. And then we can assert true is true, game.hasWinner. And you know, we can also check that has winner by row as well, right? We can self.assert true, game.hasWinner by row, right? So that should be a row of wins, right? And then we'll do maybe another one of these. We'll try and win by column. Let's check has winner and has winner by column. So now I'm going to need to drop them all in the column. So I'm going to alternate these ones here. We'll do 1, 2, 1, 2, 1, 2, 1. Here, that should get a winner in column 1. A winner in diagonal. This one gets a little trickier here, right? So for a diagonal here, so column 1, column 2, then column 2, and then column 3, column 3. So I need X, and then X again, XO, X again, right? Is that right? So I'm going to get, oh man, I have to, let me make sure I'm doing this right. So I need, come on, a little board here. Come on, draw. So my little board here. So if I put an X here and an O here, and then an X there, an O, I can't put an X there. I guess I can, then I put an O there, another X there. So X in 1, and then what? And an O, and an X, and an O, and then an X. That looks like a winner, right? Oh no, O1, shoot. I can't put O there. That's no good. I will just make O go back over there. All right, let's try that. We'll go X in 1, and then an O in 2, X in 2, and then so this is X, O, X, O. You know what? Why am I doing that? That's okay. Let's cheat here. Right? Let's just cheat. Don't save. I'm just going to give it a board. Right? We can do that. All right. So, I mean, it's not really acting because we're not really calling the code. I'm feeling a little bad here, but that's okay. We said X and X should be a diagonal win here. Right, for diagonal up. This is diagonal up. And then let's do another one of these by diagonal. And then sure, let's triple assert that by diagonal up. Make sure all of them are true here. I'll do the same for diagonal down. Down, so this one now I'll change that one to be an X. I'll put this one back to O, right? So now I've got a winner this diagonal down here. And, you know, let me just make sure it's a little further in. So let's put it maybe say, how about over here? Just so it's a little further in, it's not the very first diagonal up that we're checking. Just to see. Shouldn't matter one way or the other. And then I don't need that other test for diagonal up. We did down. That checks both diagonals. We did column, we did row, or we did winner, we did tied, did game over. So is game over should be true on all of these here, right? So anytime it's over, so we can self.assert true game.is over, is game over. I can add this to all of these ones here. They should all be true, right? We should always get a game over anytime there's a winner or it's tied. And you know what, let me put one of those back to like a space here for those, right? Okay, so game's over, game's over, game's over, game's over, game over, game over. Cool, so we're good with that one. Yeah, we could make it more specific, but we're sort of, I think we can get those in here without having to do too much duplicate work was kind of the idea. And then we also need to test those drop piece for when they fail. So let's run those, see if they work. Uh-oh, drop piece. Index, list index out of range. Oh, yeah, there is no row 6. Come on, Eric, it's row 5 and row 4. There are 6 total. All right, let's try that again. Okay, all right, so we got column was good, drop piece was good, has winner by diagonal down. Doesn't like our logic here. Is that not tabbed in far enough? Let's try it again. I think it might not have been tabbed in far enough there. I think we just upset Python. Nope, let's see. Here, doesn't like this line. So if self-board column index does not equal space and self-board and self-board, index out of range. Oh, yeah. There's 7, 0 to 7. All right, I am apparently tired. We only have 7 columns, so 0 through 6 is 7. We don't need 7 there. Okay, let's try it again for all the tests. All right, now they all pass. Cool, so we found some bugs. That feels pretty good, right? That's why we write the unit tests. We definitely want to catch those bugs. So the last couple, then we need to test drop piece raises some exception here. So dropping a piece, this is self.assert raises. When we call drop piece at, say, how do we do this? Right, we did this before. So assert raises at, what does it need? It needs a couple things. Assert raises the expected exception, so that should be a value error when we call the game.drop piece, and we don't use parentheses here, and then we give it the arguments, say like 7. So it should raise a value error if we call drop piece and give it 7 here. So let's try running that one. Oh, we can't call drop piece twice though. This is drop piece invalid index error. Okay, that one passed, and then we'll do another one here.
No, Dad.
Hey, Jack. What's up?
Yeah.
What?
Oh, yeah.
You're gonna have a cold applesauce? All right, I'm almost done. And then we will test that invalid index. This is not invalid index. This is in row full, maybe, or column full. Column full error. So if we just drop a bunch of pieces there, at say column 1, right? So we should be able to drop 6 pieces in here. 1, 2, 3, 4, 5, 6. And then when we try and drop a 7th piece, there's no more rows for it, and it should error on us. Let's try that one. All right, and that one worked. Okay, so we should have 100% code coverage. We've got drop piece, we have is tied, we have winner by row, winner by column, winner by diagonal. We have unit tests for drop, tied, winner by row, winner by column, winner by diagonal. That's it. So we didn't actually have to write the game, right? That's just in a loop, right? You know, while not game over, right? Print current player, ask which column, call, drop piece, that sort of thing. We could leave that up to our imagination, or, you know, actually write it and have some fun with it. All right, so that's all I've got for this solution. Again, we're going to pick up inheritance on Thursday, and in the theme of let's not go over crazy with work and assignments and everything that's going on with COVID land, this will be the last individual project. I don't want to stick you guys with another. I was hoping to do another one, but given we've got labs every week, and I think you guys are getting the practice. And the goal with the labs, by the way, is for you to finish. Right? If you have any questions at all about them, I will help you with it. Like, don't feel like you're not allowed to ask questions about the labs. Like, those are meant for your practice, and I will help you get it done because I want to make sure that works. Usually the projects I will give less help on, but I'm still going to help you with them. So we'll talk about the final project as well next week because we've got Thanksgiving break coming up, and then you'll have about a month for that final project. And we are about wrapped up with the semester. So, we only have 6 in so far. That's unfortunate. But I'll be working through that project backlog for you guys. Sorry for the delay. Life has been a little crazy. Thanks for your flexibility. And if you have any questions, let me know. You guys take care.